Welcome to solverfy.
In this question, we are asked to find three currents pictured in the circuit diagram that's given. We're going to do that by applying Kirchhoff's rules, both the loop rule and the junction rule. And we are going to need to establish some reference points here. So we're going to need to note the junction right here at the left edge. I'm going to call that point A. And I'm going to call the junction at the left edge point B. I'm going to call the junction at the top point C. And then I'm going to call the junction right there in the middle point D. And the purpose of this is because I'm going to need to write junction rules for a handful of these to solve for these currents. And the other thing we're going to need to do is establish some currents that are not presently listed. I wasn't currently listed. So when I2 flows over to point A, clearly I3 is going to split off and flow downward, but we're going to need one that flows upward. Similarly, at point B, when I1 flows across, we're going to have I3 coming in, and there's going to be an I4 here that goes up the side. And then I called I5 the one that goes up the left side, exiting junction A. And then at point C, 4 and 5 are going to come together to form one more that I'm going to call I6, heading down between C and D. And then 6 will split into 1 and 2. So let's go ahead and take our loop rules. I do tend to like to color code these, so let's see how we can do that. Let me grab the orange because that's not a common color on here. So the first loop I'm going to take is going to be just this top left corner where we're going to have a 12-volt potential rise minus current I5 flowing through the 5-ohm resistor as a potential drop minus I2 flowing through a 1-ohm resistor as a potential drop, and then we're back to the start of our loop, so that all equals 0. Similarly, we're going to do, how about green? We're going to do our upper right loop, where we're going to have a 9-volt potential rise, minus current I4 traveling through the 8-ohm resistor, minus current I1 traveling through a 1-ohm resistor equals 0. And now we need a third loop that includes current I3 because we haven't done that yet. And what I did that looks a little bit different, looking at how 1 and 3 are going to come together to make 4, and in order to avoid having to go backward through any batteries or anything like that, I took, maybe gray will work. I came across I3 up the outside of the circuit through the 8 ohms, down through the middle, through the 1 ohm resistor on the left and then through the 12-volt battery, although I actually started at the battery coming up with this loop. So here's my third loop. And what I have for this, starting at the battery, we have a 12-volt potential rise minus I3 times 10 ohms minus I4 times 8 ohms minus I2 times 1 ohm, and that brings us back to the battery, and that equals 0. Now let's do a handful of our junctions. We can take at point A, we have I2 coming in minus I3 minus I5 equals 0. At junction B, we have I1 plus I3 coming in minus I4 leaving equals 0. At junction C, we're going to have I4 plus I5 coming in minus I6 leaving. And then I6 will split into I1 and I2. And so one of the things I noticed is that we actually could have eliminated I6. I realized that C and D they're going to be at the same potential, and so we don't even have to worry about physically whether there's a wire there or not, since there's no resistance there. We really have I4 and I5 coming into junction C, and then I1 and I2 leaving. So we could go ahead and combine these last two. We could have I4 plus I5 coming in minus I1 and minus I2 coming out. And so this now gives us 6 equations that we can use. Although since we eliminated I6, we only need we would only need 5 of them. I'm just looking through, just double checking really quickly everything before I move on to my next step. So my preferred way to solve a system of equations like this is to put all of the coefficients in one matrix and then put all of the constants in the other. And what I do first is write them out, leaving spaces for the equations that have no variables. Like my first equation here is missing I1, so I would leave a space for it. And now to do this, you must make sure that your 1-1 entry, your first row, first column, cannot be 0. So I'm going to start with my second equation, and I'm going to rewrite it with the values for the currents on one side and then the constant on the other. So this one is going to be 1.00 I1, and then I'll leave some space for an I2 term, leave some space for an I3 term, and then plus 8.00 I4, and we'll leave room for an I5. Since I eliminated 6 as an option, we won't worry about that one, and we can just say equals 9. And now we can take the equation that I'd written in orange, and it's going to be my second row, where I'm going to have 1.00 times I2 plus 5.00 I5 equals 12. And then third, again, all of my currents are going to come to one side. There's still no I1 term for this one, but we will have a 1.00 I2. And we're going to have a plus 10.00 I3, although the 0.00 really doesn't matter. But we're just copying it directly. And then plus 8.00 I4 equals 12. And then next, it doesn't matter which equations we choose. I'm just going to keep going right down the list. I'm going to take this one next. I2 minus I3 minus I5 equals 0. I2 minus I3 minus I5 equals 0. And then I'm going to have I1 plus I3 minus I4 equals 0. And now we are ready to set up a coefficient of constants. So we're going to just fill in really quickly that we're going to have a 0 I2 here and a 0 I3 here and a 0 I5. And we have no I1, no I3, no I4. We have no I1 and no I5. We have no I1, no I4, no I2, and, oh, oops, this one is supposed to be minus I4 with no I5. So let's fix that. Minus I4 and then I5 is 0. So we'll set up what we call matrix A, which is our coefficients. 1, 0, 0, 8, 0. Next row, 0, 1, 0, 0, 5, 0, 1, 10, 8, 0, 0, 1, negative 1, 0, negative 1, and last 1, 0, 1, negative 1, 0. And then we will set up matrix B, which is our constants, 9, 12, 12, 0, 0. And then we will calculate A inverse multiplied by B. And this gives us 179 out of 211. 452 divided by 211. 36 out of 211. 215 out of 211. And lastly, 416 divided by 211. And putting these into decimal values, we get 0.8483, 2.142. I haven't worried about sig figs, by the way. 0.1706, 1.019, 1.912. And these now correspond to the values we've been asked to find. So I1, if we put amperes on all of these, we only need the first three. I1 is going to be that 0.8483 amperes. I2 is 2.142 amperes, and I3 is 0.1706 amps.